Hi everyone, welcome to Today at Sci-Port. I am your gracious host, Greg Andrews, the Planetarium Manager. Thank you very much for joining me for another session of Starry Night. Today, we will focus on the astronomy content within the constellations of Corvus and Virgo. Feel free to comment below, or you may email me at gandrews@sciport.org. Let's get started. In order to find the constellations of Virgo and Corvus, we first want to locate the Big Dipper. And there it is. And I've mentioned before how the handle of the Big Dipper, these stars that make up the handle, how they form a curve. And you can follow that curve, or what we can call an arc, to this star called Arcturus. Hence, you arc to Arcturus. If you continue along that same curve, that path, it will lead you all the way to this star right here, and this star is called Spica. And Spica is a part of the constellation of Virgo. And then underneath Virgo is this constellation, and that is the constellation of Corvus. So that's how you can find those. Let's get into the stories now. The constellation Corvus is one of several birds in the sky. According to the legends, Corvus is a raven, or he's sometimes depicted as a crow. He's in the sky as a form of punishment. When it comes to the stars that make up Corvus, the first one I want to talk about is called Algorri. And Algorri translates to mean raven or crow. If you have binoculars or a telescope, you can see that there is a nearby star. The next star is known as Gina. And Gina translates to mean wing. Now, this star is oftentimes paired with Algorri. So there are some cultural references that refer to these two as a pair of stars. I don't want you to get confused because Algorri already has its own other star, okay? But together, these two stars translate to mean the raven's wing. So Gina means wing, Algorri means raven, the raven's wing. The next star is called Menkaure, and Menkaure translates to mean the beak. And then this star is called Crux, and Crux doesn't have a known definition. But if I am looking at the artistic perspective, I would think that this translates to mean the feet of the raven or the feet of the crow. There is a galaxy that is inside of Corvus. Let's see if we can bring it up. Right there. And this galaxy is known as the Antennae Galaxy, or actually say the Antennae Galaxies. So let me switch to a picture so I can explain this in a little bit more detail. The Antennae Galaxy is a pair of interacting galaxies. It's a matter of personal preference if you want to refer to this as a galaxy or galaxies. What we do know is that this collision is creating star formation in the heart of this area, as well as along the tidal tails, or these streaming looking aspects of this galaxy. These tidal tails are a signature way to show that these galaxies are in fact interacting and merging with each other. In a few billion years, this will in fact be one galaxy. Studying galaxy formation and the collisions thereof is a very important aspect of astronomy. It helps us to know more about our universe. What's very lovely, as this video is showing, is that our universe provides us a platform of all of these interacting galaxies. And by studying those interactions, we can develop sort of a stage-by-stage play of what happens when galaxies collide. We don't know everything, but we know enough to be able to create simulations such as what you see before you. Again, these collisions take place over billions of years. Our own Milky Way galaxy is going to start colliding with what's known as the Andromeda Galaxy in a couple billions of years. It'll be very fascinating to watch if you can stick around. M104 is 31 million light years away from us, and it has a diameter of 49,000 light years. In other words, it's smaller than our own galaxy. It's known as the Sombrero Galaxy because of its shape. It has a bright nucleus and then a bulge of stars around that nucleus, along with a very dark band across its equatorial plane. And this is what we can see in visible light. But if you observe this same galaxy using infrared, you'll notice that that dusty band is even more distinguished. And if you observe it in X-rays, you don't get a band at all. You just get a bunch of bright spots that are projecting X-rays. And so these are actually X-ray sources. You can think of them as hotspots within this galaxy. But all of these pictures together generate information that allows scientists to explore and learn more about galaxies. We don't want to just examine a galaxy using visible light. We always want to try to use other forms of light as well. Now that we know a little bit more about the Sombrero Galaxy, we're going to back up, and I'm not going to go too far. I want to be able to point something out first. Do you notice amongst the background stars, there are these red ovals? And let me take away the stars. You see all those red areas? That is representing the location of galaxies. And what is intriguing about Virgo is that pretty much wherever you look with your binoculars or telescope, you'll start to see galaxies, right? They just start to pop out. They have some really cool names as well, but most of them have like a number designation. This one says NGC 4664. There's just so many galaxies in here. And in fact, we're going to head over to, there you go, right here. In this area of the sky, this is right above the constellation of Virgo, which is below us. Over here is the constellation of Leo, and over here is the constellation of Coma Berenices. And in here, there's just a galore of galaxies all in this area. And what this helps to represent is what we identify as the Virgo Cluster. Let me bring up another picture so that hopefully I can explain this better. Behold the Virgo Cluster, or rather, a part of the Virgo Cluster. This image contains scores of galaxies, but the Virgo Cluster is home to roughly 1,300 galaxies. Now, I am not going to go and point out every single galaxy in this image, but thankfully, someone took the time to label most of the galaxies in this particular picture. I've mentioned the word cluster before in the context of stars. In other words, a bunch of stars can come together and become gravitationally bound, and hence they form a cluster. The same principle can apply to galaxies. You can get a bunch of galaxies that become gravitationally bound to one another, and they become a cluster. It's not to say that all these galaxies are going to crash into each other and form and merge to become one big super gigantic galaxy. No, we're not saying that. But these galaxies within a cluster are gravitationally bound to one another. What happens if you start to merge galaxy clusters? Think about this. You have a cluster over here, you have a cluster over here, a cluster over here, a cluster over here, etc. But they all begin to merge and become gravitationally bound to one another. So what do you call clusters of clusters? Well, the answer to that is what we call a supercluster. And you can think of this as a metropolis of galaxies, where there are just thousands and thousands and thousands of galaxies that are forming, or I should say rather, gravitationally bound to one another. And what this leads us to understand is that there is structure, that there is a formative process in our universe. As we take this flight through all these galaxies, you realize that galaxies come in different sizes, even some different shapes. Some look nice, some look not so nice, but there is a process to it. And that's something that's really interesting. There is one more galaxy that I want to show you all. And this galaxy is super duper important to the field of astronomy. this one provided a groundbreaking announcement last year. I don't know if you all know what I'm talking about, but let's zoom in on this one. This is called M87, also known as the Virgo Galaxy. I get super duper excited when I mention this galaxy or I realize it's going to be out in the nighttime sky. Let me just show you. What I'm going to do now is show you all a video that is about 100 seconds in length. There are At the end of the video, it's going to show you an object, and that is the object that gets me super duper excited about M87. Two things I want to point out, and that is that M87 has been observed over the years through different types of telescopes and observing platforms. Some of these particular instruments would receive an upgrade. For example, the Hubble Space Telescope has been upgraded several times. And scientists will say, hey, let's go back and look at M87 using the new and improved technology. The second point of emphasis is that M87 was observed through different parts of the electromagnetic spectrum. In other words, it's not just visible light, there were also invisible forms of light that were utilized to observe M87. Let's go ahead and play this. And what you just observed, or what you were viewing in that at the end of that video right here, is the first ever image of a black hole. Now, we've been able to stimulate black holes. We've been able to sort of have an artist rendition of it, but we had never been able to directly image a black hole. And that's what we were able to successfully do here. Actually, this is the event of the black hole, but it's close enough though. This is just super duper exciting. There was so much information that was gleaned from this, and this is just sort of like the first wave. So this was a big announcement last year. There's so much more that I can say about this, but I'm going to stop. Thank you once again for joining me for this Starry Night presentation. I hope that I have inspired you to explore the nighttime sky. If you have any questions or comments, feel free to type them below, or you may email me at gandrews@sciport.org. Stay curious.